Bonjour. Thank you for joining us after lunch. We are the LoRa Alliance, and we are here to talk with you about LoRaWAN technology. Next slide, please. Okay, the members of the LoRa Alliance are those who manage the LoRaWAN standard. This is a networking IoT connectivity. LoRaWAN is a low-power, wide-area network connecting devices, devices to, sensors rather, to a network. Recently, we were granted recognition as an ITU standard. And my role, my name is Brenna Campbell. I manage the marketing and content and communications for the LoRa Alliance. These gentlemen with me here are our members. Next slide, please. We actually have over 500 members. This slide, very small logos, but that's the only way we can get all of our members on the slide. We have nearly 500 members and nearly 1,500 people participating with us to manage the LoRaWAN standard. When you think about an alliance, you can think about Wi-Fi. Wi-Fi was also, it started as an alliance because that's the only way to get everybody in the world to use the standard in the same way. So that's the direction we are headed to. We have members working on the technology, on the marketing, and on the certification of our devices. Next slide, please. Now we're here today to talk about LoRaWAN and how it supports sustainability. LoRaWAN can be used in urban and rural environments, and when we talk about sustainability, we're not just talking about preserving resources, we're talking about using them to the best of our ability to ensure that people have clean air to breathe, enough food to eat, water to drink, but it's also about financial stability for our businesses. How can we sustain ourselves as people, sustain our businesses, but then of course sustain our planet too? Our members today will talk about solutions that are both maybe in a forest, detecting wildfire smoke early before a wildfire gets out of control. Or perhaps it's about an operational efficiency. So operational efficiency, living better lives, and using fewer resources to do more. That's really what we're all about. Okay, next slide, please. These are our panelists. And we're a little bit out of order, but Ben Jones is our marketing director from Dryad Networks. Nicola, to my left, Nicola Jordan is the COO of Actility and Abbyway. Stefano, second from the right, or left rather, is the head of sales for OrbiWise. And finally, Christian Ulrich is the VP of Business Development at TEKTELIC. Next slide, please. Okay, now we're just going to do a round robin, and I'm going to have each of our presenters share with you about themselves and their company, and then we will ask some questions. So I will hand it to you, Nicola.
Sustainability, I can do it in French or in English as you prefer, but there is no remark. I will continue in English. So as you can see here, what we are drawing, and this is our image, is related to a tree. So of course this. So, and to make the things is the mind over the matter, and if we think about sustainability, is the capability over IoT sensors, you are all here for IoTs, is the capability really to have to mediate all the data coming from large types of sensors and be able to retrieve all this data to the clouds, to be different type of jobs, analytics that cover the different ideas that you just have start to share. So the core business of Actility right now is to do this link, this connectivity capability for private networks inside enterprise or a smart farm or whatever, or other public networks provided by public service provider like Orange, be able to retrieve this data, to intermediate this data, be able to read them and to exploit them for different use cases, including, of course, saving the planet. In few words, so this is what Actility is doing. Thank you.
Thank you very much. Bonjour, everyone. So I'm Ben Jones, Managing Director at Dryad Networks, and we are a Berlin-based startup, fairly small at the moment, maybe 30 employees, but we have just closed a Series A funding round for 10.5 million euros, so I think you'll see us growing quite a lot over the next few months. And basically, we create hardware and software to detect forest fires ultra early. How do we do this? We do this by deploying a network of sensors in the forest itself, so literally on the trees in the forest. And these are very accurate gas sensors which can detect minute changes in gases very early, so things like hydrogen, carbon monoxide, carbon dioxide. And by being able to detect the change in gases so early, we can then alert the end user in the smouldering phase of the fire, which is critical, and they're able to get to it very early, way before it has properly ignited and gone out of control, allowing the authorities to extinguish the fire safely and easily. And we know that wildfires are a huge problem, as some of these stats allude to here. So some research says that wildfires contribute to fully 20% of global CO2 emissions, also cause huge kind of biodiversity losses and financial damages as well. And we know that humans are to blame, either directly or indirectly, for 80% of wildfires as well. So we believe that it's our responsibility to address this problem as well. Next slide, please. And this just kind of demonstrates what I was saying in terms of the speed of detection. Obviously, when it comes to fires in very dry environments, speed is everything. So until now, many of the approaches have been cameras, satellites, CCTV, etc. But we believe a sensor network is the way forward, and that's us.
Hello, my name is Stefano Cricco, Head of Sales of OrbiWise in EMEA. So next slide, Brenna, please. Okay. OrbiWise is a company in Geneva, Switzerland. We have, since the very beginning, embraced the LoRa standard, and we are in the LoRa Alliance since 2014, 2015, so the foundation basically of the LoRa Alliance. Our main products, we are software developers, and our main products are basically the network server, so the connectivity platform for LoRaWAN. And we also are working with partners, and we have developed our own vertical solution, which is very well connected with the sustainability, and especially environmental sustainability, because we have developed a noise monitoring solution which is starting to be used in some cities to monitor the noise level, as well as in industrial environment. Next slide, please. So what we have done for our solution is we have developed the sensor and the application that comes along with, together with a number of monitoring features on the different noise levels in the city. And we are also developing some additional features for the sensor, which will include probably in the future noise direction and noise filtering in terms of frequencies. As well, we have been working with some other companies, partner companies. One is namely in Corsica, where they have developed a private network, which is not a public network, officially public network, but they have deployed a number of sensors to monitor the quality of air, the quality of water, both the water that is drinkable water and the water which is for being Corsica to the beaches. Air quality is checked by the use of weather stations and CO2 sensors, and water quality is controlled for drinkable water and beaches to save natural resources. That's about our...
Thank you. So nice to meet you. My name is Christian Ulrich. I run TEKTELIC's business in Europe, Middle East, Africa, Asia, together with the team. I think the difference in the slides here is speaking very well to the diversity of the LoRaWAN ecosystem in the LoRa Alliance. Next slide, please. We're a company that really come from a carrier grade background, and we entered the LoRa Alliance and the LoRaWAN ecosystem building carrier grade gateways to deliver the infrastructure for deployments, both operator and when municipalities, when enterprises are building LoRaWAN networks, they often do it with our gateway products. We are headquartered in Canada. We have a quite large presence in Europe as well. Lots of software development, integration work going on over here. And in 2019, we also entered into the device space and are offering today a wide variety of LoRaWAN devices. We kind of have a tagline that goes through all the development decisions we take as a company, which is that whatever we bring to market has to solve a real-life problem. There are a lot of companies in the industry that are fascinated by technology and fascinated by the possibilities technology gives us to develop gadgets and gizmos. And the IoT space is definitely, there are many good examples of this. But what for us is important when we put effort into developing is that whatever we bring to market needs to address and to solve a real life problem. And that's where the focus on sustainability and the focus on reducing energy consumption, the focus on conserving the earth's resources is mirrored in a lot of the products that we are offering.
Thank you. So now I'm going to ask a few questions of our members, and then we'll give you a chance to do that as well. Okay, so Christian, this first one is for you, and we would like you to tell our audience, what do you think, or what does TEKTELIC feel the most important role is for the LoRa Alliance with respect to sustainability?
So I think one of the things I want to highlight the LoRa Alliance for is that technology alliances very often are just that, focused on technology and focusing on promoting one technology over other technologies. One of the differences in the LoRa Alliance is that there's actually been a focus on creating solutions for a better world and to guide members of the Alliance to think about how can we contribute, how can we work together to build solutions that not only create an economic advantage, but also create better living conditions, better sustainability, better climate profile to the planet. And bringing the ecosystem together and endorsing and recommending us to work together is one of the things I believe LoRa Alliance is doing very well.
Thank you. Yes. Okay, this next question is for you, Nicola. How can businesses or facilities or factories use LoRaWAN to meet their, say, their sustainability goals or perhaps their United Nations sustainability development goals?
It's a very broad questions because the number of use cases related to that subject are huge, and this is the reason why it's called Internet of Things. Internet, there is no limit. So the type of problems that we are solving related to this, let me give you two examples at the opposite and quite critical. First one, in Africa, for the conversations, there is some associations related to defend the wild animals. And there is now using IoT technologies is a way to protect the animals by providing So in this specific associations that cover 5 million hectares areas in Zambia and in different countries, the capability to, of course, monitor and protect the animals, monitor them, track them with this type of trackers and sensors, monitor the gates of the access, monitor the quality of the water where they may drink, really to be able to protect the animals. So IoT has bring, because the territory is so wide that there is impossible for human in terms of resources to control everything and to protect the animal. IoT is a way to really remotely control and protect the animal. At the opposite, if we are getting back more to what we are concerned right now in quite short term, is the energy efficiency. Not only because of the cost, because everything is related to the fact that we have to limit the CO2 emissions as much as we can to protect the planet. And for this challenge in the energy grid, there is IoT bring a very key elements related to what we call the demand response. Today, up to now, let's say, the energy systems and the grid were trying to predict over statistics tools what was the consumptions has to be produced. But in reality, when you think about putting wind turbine, solar panel, you are not sure if you have wind or wine, and you are not able to be sure that you can really get the energy when you need it. But if you have the capability, thanks to the IoT, to control the consumptions at the customer side, for some customer of them, because they don't produce all the time, they can put on the engine only when there is wind. And for this, you need to do it in real time. Means that you need to interconnect the capability to know what is the energy needs in a network, to know your production cycle, and to synchronize them thanks to the IoT, where you interconnect the systems with IoT, LoRaWAN systems to the grid and be able to switch it on or switch it off regarding if you have green energy available or not, when you can do it. And this demand response approach is really something that will be added more and more into the grid over at the national wide, and of course will be downscaled also to the enterprise, and one day also at homes, so more and more. So that's really two examples of opposite subjects that IoT may bring, but there are thousands of other examples that probably my colleagues may describe.
Would anyone else like to add to that? No? Okay. So yes, so speaking of vast areas that LoRaWAN can cover, Stefano, I wanted to ask you how LoRaWAN makes scalability of infrastructure, how it makes it easier to scale, and how infrastructure becomes more efficient.
Well, we didn't mention, we didn't get into the details of LoRaWAN technology, but just to make it quick and simple, LoRaWAN allows you to build both public and private networks. And the reason is that it's a technology that makes use of unlicensed spectrum. So anybody can use the technology to build their own network. It's not something that operators that you are obliged to go through operators. Of course, operators can also use that and provide connectivity, LoRaWAN connectivity to the public. Per se, this is already something that allows you to have a much wider and dense coverage than just with public network. We know that the limitation of public networks in many cases is given by the fact that there are some areas that are not economically convenient to be covered or difficult to be covered, and so the operators don't cover it because they cannot reach it. It doesn't make a lot of sense for them. But I mean, we are not thinking in this case of people, we are thinking of objects and sensors, and animals, as Nicola was mentioning before. So there are areas that you can cover with LoRa that are not covered by other technologies. So you can reach areas, really remote areas. And then this is one thing. The second thing about scalability, well, in many of the cases, when you build a connectivity platform, a network server, the technology that is used now allows quite easy scalability. So you need just to add virtual machines, so capacity, and you are nearly unlimited capability to cover a number of antennas, a number of gateways, and a number of sensors. Of course, there is unlimited doesn't mean anything because there is always a limit to technology, but there is no theoretical limitation of the number of gateways and the number of devices that you can connect to a network. The topology of the network it's quite easy. It's quite simple. It's a star network. So it's I mean we have some examples already of big networks with hundreds of thousands of devices connected and thousands of gateways connected. I think that Nicolas can mention it, I can mention it, because some of our customers have this size. And of course, this shows already in practice that scalability is possible. And as I mentioned before, also the coverage of areas that are not easily reachable by standard technologies is really important. Regarding other let's say, wireless technology, one of the advantages of LoRaWAN is, of course, also the range that can be covered. In rural areas, you can arrive to 10, 15, and even more kilometers, depending on how the situation of the orographic situation is. So I think that there are not very many technologies that allows you to have this type of coverage.
Thank you, Stefano. Appreciate that. Okay, now we've talked a lot about scalability and infrastructure, and I'm going to ask Ben more about who is it that is implementing LoRaWAN, because I think the answer might surprise you.
Thank you for that. I would say the question we get asked most at trade shows, and we've been to a few trade shows already this summer, is great technology, huge problem. It sounds like you're kind of on the way to solving it, but who buys this? And I guess the simple answer to that is anyone who wants to protect their forests. So that can very much depend on the context of the country, kind of who has jurisdiction and kind of whose remit is it to protect forests. For example, in the UK, it might be someone like the Forestry Commission. In America, as you expect, there might be more kind of private forestry ownership. There can be kind of state parks, it can be municipalities, local authorities. So they're kind of our first, I'd say, vertical, is anyone who kind of has these vital assets to protect and sort of in their kind of, it's their role and responsibility to look after them. The second kind of main group or vertical would be the firefighting community and sort of disaster response teams, because this very much aids them in their mission to, of course, stop mega fires happening or kind of, raging. And then the third one, which I guess was a slight surprise to us, would be utilities companies. So increasingly now utilities companies, because they are sometimes to blame via their power infrastructure and grid, etc., for wildfire starting. They're having to increasingly sort of mitigate against those risks. And we're seeing in America especially that regulators are kind of showing some teeth when it comes to utilities companies who, if the fire can be attributed to a particular company and, that fire then went on to become a mega fire or, cause lots of devastation and damage, then regulators are showing they do have the appetite to, hit these companies with huge fines. So these companies are looking for innovative new ways to mitigate those risks and to stop the potential kind of huge liabilities. So, for example, now we are in discussions and indeed we're doing trials with PG&E in America, obviously a utilities giant. So I think that just shows that, increasingly companies are looking to new technologies, new methods, new techniques to help them deal with, emerging problems and growing problems as well. So there are kind of three main customer groups, I would say. And then also we're starting to get a bit of interest also from rail companies. So in Canada, we're in early discussions with a big rail kind of network company, again, because sparks from trains and train tracks are often to blame for starting wildfires again, especially in dry countries. So there are groups.
Actually, I'm wondering, would each of you like to answer this question about who is buying your technology? I know I find it interesting. Farmers buy the technology for precision irrigation, for instance. So we have farmers, we have building management, building systems management for air quality, I think Nicola mentioned. Cities, municipalities wanting to manage the street lights or the weather or people counting or even your parking ramps. There are all of these applications, and it's not just highly technical people. It's everyday people as well. And then, of course, utilities is our biggest market. But that was my 2 cents. Would anyone else like to add to that?
Large corporates, of course, are more and more demanding. There are more and more tenders and answering to really different use cases by increasing the efficiency of their production lines, increase the security aspect about what we're doing, controlling also, we get back to the energy and fluids, about how many, really what are the energy consumptions, but gas, water, electricity also. And so, yeah, large corporates, local authorities, public authorities, of course, more and more smart city, you mentioned it, for a lot of use cases. Anyone can be interested. In fact, I don't know if someone would like to be, so you are all interested, so come to see us later on at the booth. Yeah. Of course. I don't know if someone would like to add something, otherwise I give you back the mic. Okay.
Christian? Oh, come on, Christian. You have things that people use for health. That's interesting.
Yeah, actually, so one of the areas that we are developing a lot in the IoT space is the smart healthcare. We're not only an infrastructure provider, as I mentioned, we also build actual devices that go out and solve real-life problems. And one of the problems in the healthcare sector is that whenever somebody is going out from a surgery in a hospital and sent home after this, there is 3% of all surgeries that are made worldwide. Patients are getting complications in the time span between being released from hospital and contacting their own physicians for a follow-up treatment. And no matter which hospital system in the world you have, whether private or public, it always leaves the patients in a limbo in that time period. So it's a significant problem, both for human health, but also for the economy of the health insurance and the societies. We developed a sensor based on LoRaWAN that actually track people's vital signs in the time from being released from the hospital and until they receive follow-up treatment. And due to the range, the coverage of LoRaWAN networks, we can actually monitor people through municipalities, through large areas in that time period. So there's a lot of development going on where the technical side of it is actually the easy one that we enable using LoRa technology. The challenging one is embedding it into the workflow of hospital and health insurances, and that's where we are spending a lot of time and energy right now. But there are many exciting things happening there.
Sorry, I might just add as well, just in the week of COP27, that when it comes to obviously forest fires and wildfires, for us, obviously, there's more and more countries interested in this technology. Wildfires are afflicting more and more countries. It feels like, every summer there's kind of record fires in new countries you wouldn't even expect to, suffer from wildfires. For example, even in the UK, this summer just gone, some pretty devastating fires. So I guess depressingly in some ways, you know, it's a problem that with climate change is getting worse, and the frequency and the intensity of the fire season is continuing to, you know, intensify. But I guess for us, when it comes to kind of addressable market and customers, there's more and more of them as well.
Thank you. Okay, we are going to talk a little bit more about operations in large enterprises. And Nicola, can you talk about predictive maintenance and how that plays a role in conservation?
Predictive is really something that IoT can really enhance. Why do I keep my heating system on in the morning knowing it's going to be 20 degrees on the afternoon? And I know that it's going to be because it's easy to get the weather forecast. Why do I keep my heating on? So that's be predictive is key. Predictive and monitors over even the capacity to control my heating related to what the weather forecast is one of the first examples. But mainly predictive maintenance is related also to attach to potential lot of systems that they remain operational and know they remain operational and know in advance if I may have an issue with a pump. I need to predict if there is a water linkage may come by listening my pipes. If over my city, my factory, I'm listening my pipes, and or there is a pump and I'm listening, is because with AEA systems I can get the vibration, and as soon as the vibrations start to sense slightly, it means that maybe I need to send someone to monitor it before it breaks down and get an issue in terms of productivity, but also pollutions consequences related to the water pump systems, for example, or filtering of the water. And checking the quality in advance if I pre-detect that the quality of the water are changed, and monitoring in times to really get in advance before we get the incident. That's the really something that is without IoT, and we thank all the use cases, the coverage of LoRa and the flexibility and the number of sensors that we are talking about 1,000 type of sensors available over the marketplace, over where you can really, mainly on most of the use cases that you may have in mind, there are certainly already LoRaWAN solutions today available, because thanks to the LoRa Alliance effort and all the companies, that all of the works that we're doing together. So covering and going more to the predictive, it's a gain of money. It's not a cost, it's a gain of money. And also, if we related to getting back to our project, is really help to solve also the sustainability issues that we are talking about.
Thank you, Nicola. Okay, Stefano, let's talk about how quality of life and sustainability can be improved by supervising environmental pollution using LoRaWAN.
I think we have already mentioned the fact that with LoRaWAN there are many different use cases that can be implemented. Actually, the technology supports a huge spectrum of cases of solutions. Regarding more closely environmental stuff, I have already mentioned that there are a lot of sensors already existing since many years, which can monitor CO2 level, which is quite important in this moment, and also other polluting elements level, so the air quality in general. And there are many sensors that are actually LoRaWAN compatible. I mean, they can transmit over LoRaWAN. So making LoRaWAN a technology to allow to monitor environmental parameters. As I mentioned, weather stations, but also simple sensors. And this is a direct measurement of the quality of different parameters. I mean, I mentioned air, water. We have developed, because this is a bit of a niche segment, because we had a request some years ago from Geneva and from the Swiss government to develop a system to monitor noise. Noise is also a source of environmental issues, which is often not monitored properly. we know that the noise level that we have in here is actually higher than what should be allowed, because it's higher than the 70 dB average. Of course, 70 dB you don't feel it as creating issues directly, but in reality, a long exposure to such a level is not good for your health. And you can monitor this level. Of course, the standard technology uses sonometers. Sonometers are quite expensive devices, sensors, that are really normally made of a microphone, 360 degrees, with high quality and so on. But the cost of a single sonometer, in many cases, is several thousand €. So what we did was together with the Geneva government and the local government, was to develop a sensor that was much, 10 times less, okay? More than 10 times less, even in numbers. And to allow to have monitoring, the monitoring of the noise level much more dense, and leaving the sensor there for a long time, so that you can create a map and have a visualization of how the noise level goes up and down during the day, during the night, during the weekend, and so on and so forth. Actually, there is research which is being done by Geneva and by an a foundation in Switzerland, which is responsible for the noise monitoring, that is actually checking the level of the noise in relation with the simulation that are often used, making use of patterns. Of course, simulation is officially recognized as a method to control the noise level, but it's always useful to double check that simulated data using patterns of noise generated by cars, by trucks, by any source, by trains, by airplanes, is, let's say, checked against the real data that are measured in the field. So this is how actually our solution can help and supplement what is done by simulation.
Great. So we've talked a lot about thinking about larger infrastructure, and you're hearing some real examples of how our members can be very nimble in responding to market needs. And so thank you, Stefano, for that. And we're going to hear a little bit more from Ben about Dryad's revolutionary approach to wildfire prevention and detection.
Thank you very much. So yeah, what makes our solution revolutionary or game-changing? Well, as I mentioned, as you saw in that kind of graph in my introductory slide, the way we see it is the approaches so far have been ocular-based, so cameras, satellites, CCTV, drones, watchtowers, if you want to go further back. So, all based on seeing the fire. What we change is we kind of smell the fire instead. So that's obviously a paradigm shift from kind of one sense to the other. And that does allow us to detect forest fires, wildfires, way sooner. So in those first few minutes when it's still smouldering, frankly, it's so quick you could probably put it out yourself for you to get there. But definitely with the aid of the authorities, very easy job to extinguish safely and effectively, and very much minimizes the risk of fires properly catching and turning into these infernos that we see on the television. So it's the shift from seeing the fire, which each of the sort of ocular approaches have their limitations. Obviously, the speed of detection is the biggest weakness, but also very hard to deploy a network of cameras deep into forest locations. Satellite-based approaches are kind of riven with issues about legislation and kind of real-time imaging, things like that. Also, lots of these fires, start deep kind of underneath, quite dense canopies in some areas. So the satellites are relying on it kind of breaking through the canopy, or at least the smoke breaking through. That can take a few hours, by which point, you're dealing with a much different proposition to what it would be if you got there in the smouldering phase. So it's the speed of detection mainly, and it's the change from seeing the fire to smelling the fire. And of course, the fact that they're fairly, the sensors themselves are, fairly affordable and low cost. So one sensor costs about 48 euros, and one sensor will cover an area of about 1 hectare. So it's very much possible to cover quite large forest areas affordably. So for us, how we're changing the game and kind of being at the vanguard of that shift is the affordability, scalability, and the durability of these sensors. So because they are solar powered and there's no batteries inside them, so no kind of toxic materials, just a solar panel and a supercapacitor. So the sensors themselves can happily sort of sit in the forest for 15 to 20 years, very much weatherproof as well. I'm very happy to be kind of left in very low light areas. So very much a kind of set and forget solution in your forest. Hopefully you'll never get the alert on the cloud platform, but if you do, you'll know exactly where to go. So that's how we're revolutionary.
Wonderful, thank you. Okay, Christian, we're going to go back to you and hear more about how TEKTELIC is impacting sustainability, and I will just leave it there.
It's always difficult to come after Ben and talk about something that seems important after hearing about, catastrophic wildfires and, all these all-consuming natural disasters. But as you related to before, we have COP27 this week, and one of the things that is behind many of the natural disasters we see those years is the increase in carbon dioxide emissions, and a lot of the things that we work on is to reduce that going forward by reducing energy consumption and more importantly, reduce energy waste, because lots of the intentions to reduce energy consumption and to, live with less air condition in the summer, less heating in the winter, is very intentional, but when everybody is making their everyday decisions, is everybody really following up on their good intentions? One of the areas where a lot of energy can be consumed, and Nicolas touched upon this also in his presentation before, is wasted energy in manufacturing. And one of the things that is being developed a lot in these years are solutions where you go in, you analyze not only from a single source, not only from the air conditioning system in a building, not only from certain process manufacturing parts in a manufacturing industry, not only from certain furnaces in a steel plant, but across the factory. How can you optimize your processes to reduce waste of energy? And we work with lots of companies in this space. We're just publishing another case study on our media today about a company who actually have been doing that for many years and have been struggling with always having siloed approach, because you could get sensor data from one or the other piece of device, but it was extremely difficult to combine that with sensors and data from other sources that could give you a complete view of the process and how you could manipulate that process to reduce energy waste. And switching from other technologies actually to use LoRaWAN for that purpose enabled this company to take sensors coming from the many different members of the LoRaWAN ecosystem. You saw it in the presentation slide up here. There are over 500 companies contributing, all with their individual solutions, their individual devices, actuators, sensors, and being able to tap into that ecosystem and find the sensor that can actually help you retrieve that set of data that's necessary for this particular piece of information that helps you paint the big picture of a manufacturing plant's energy consumption and, more importantly, energy waste, because that's something that can be reduced and taken away without a loss of productivity, which is what we all want at the end of the day. Using LoRaWAN for that purpose was what enabled them to really make their solutions so much more efficient. And they're now rolling these out at manufacturing plants, starting in Scandinavia and then spreading it across Europe. And all this infrastructure is based on private enterprise LoRaWAN networks operated in the facilities, where we are proud to be the provider of that infrastructure, but happy to support solutions like this.
Wonderful. Thank you, Christian. Okay, Nicola, we're going to have you finish us off with maybe tell us a little bit more about what you see of LoRaWAN deployments in France.
Another very broad subject. France is very interesting structure because a lot of LoRaWAN technology have started in the country. In France, the technology has been co-invented in France long time ago now. But in reality, the level of maturity of LoRa has been extremely good. I think major companies today are really considering this technology regarding their needs. The market have started with mainly coming from what we call the public networks, means that you have a connectivity over the air right now. Here we are talking provided by the telecom service providers, and we were one of the only country with two networks previously coming from two different service providers, quite competitive environments. Most of our countries there is only one player. Additionally, that there are other alternative technologies as a competitor, but to LoRa. So now there is a consolidation aspect where and Orange is still continuing that and keep their commitment on this technology. That's really complete the cellular technology. So the public network is there, and we cover specific use cases over the public network. If we are getting back to tracking, if I want to know if my car is in Bordeaux, in Lille, in Paris, I need a public network because installing a private network over the size of the country is a little bit expensive. But at the opposite, the trends and the maturity and the number of tenders coming from utilities and large corporates and smaller companies and innovating startups that embracing the LoRa technology to be able to address private networks, because you can see LoRa also as, let's say, the Wi-Fi for IoT, for the newbies who are in the room here, where it's as easy to install a hardware, a gateway hardware, and then having the network and start to add the sensors and connect it to your cloud application. And the trends of regarding the needs and on the different use cases definitely in France is there. The fact that Bouygues Telecom, for those who are tracking and as Opginus have decided to end, though, so people are moving. Most of their customers are moving to Orange for those who are really remain related to the public network need, or going back to companies like Actility and others for moving to private deployment. As long as they have a campus limited area to cover, they don't need to rely on the public service provider. We can, company like ourselves, we can provide managed network for them in the private infrastructure. So there is the trends of people are moving to the private or either to Orange. And also, most of you heard about the Sigfox issues, an alternative technology that is not LoRa-based, more vertical oriented. And now, regarding the ecosystems of sensors manufacturers, all of them have moved from Sigfox to LoRa, or maybe keeping the duality technology capability, because there are still a lot of, even abroad, Sigfox network. But anywhere, you will be bystander sensors. Let's say that to summarize quickly, take a picture of what's happening in France right now.
Thank you very much. Okay, I'm going to ask you to go to the next slide briefly. Okay, so thank you all for being here to enjoy these presentations. And before I open it up to other questions, I just wanted to encourage you to think about joining the LoRa Alliance. As a member, you get to collaborate with people like this. Anyone in the ecosystem. We have device makers, we have network operators, solution providers, gateway makers, the whole ecosystem is a part of our alliance, and as Christian mentioned, it's a very collaborative group, and we are always excited to talk about it and promote it and encourage you to stop by our booth, which is over there, G20, and learn more about the benefits and learn more from our members. Okay, we can go to the next slide. Okay, that's our thank you slide. Now, I think what we're going to do here is Pauline is going to walk around with a microphone with anyone who has questions, and you all, whomever answers it, you actually have to come up to the podium to answer. Okay.
Même en français, si vous voulez, si vous préférez, si vous n'êtes pas à l'aise avec l'anglais, vous pouvez répondre en français. Stéphane aussi, et Christian, on peut vous répondre en français si vous préférez, si vous êtes plus à l'aise. Ou en anglais. Ou en italien. Ou en néerlandais.
In English, I'm afraid. For business critical or industrial critical applications, LoRaWAN being in a unregulated radio frequency area, is it suitable for those sorts of applications that really could be industrially critical, given that, you know, lots of people can jump in and override the frequency?
I didn't get a chance to walk to the podium, but I'm happy to take the question. So obviously, if you ask a slightly biased panel like this, you will get the answer: yes, it is. I think what's really critical is that no matter if your network is operating in a licensed or an unlicensed spectrum, there is risk of interference with the network. And the key is to design your network and to operate your network in a way that's suitable for the application, which means that if you sign up with a network operator, these people can give you SLAs. These people can give you a certain guarantee for the coverage, for the percentage of packets that are actually coming through the network, such as they can do in a cellular network. And it really comes back to the way the network is designed and the expectations you have to the network. And then there are applications where LoRaWAN as a technology is not really suitable. If you need low latency, if you need high data rates, if you need real-time acknowledgement of each and every package that go to the network, and such applications exist, then there are other network technologies that serve different purposes better. So LoRaWAN is not the answer to all and everything, but plenty of mission-critical applications, plenty of industrial critical applications are successfully ran over LoRaWAN network that's built with equipment that is of the right quality, where the network is dimensioned correctly and where the network is managed by somebody who know what they're doing.
No, I agree. So we are deploying end use cases in the health systems, in the nuclear plants, military, army, and what you have to think about is the additional. There is a lot of strategy that I won't detail right now on the way LoRa and the LoRa Alliance has think about to minimize any radio perturbation around it. But what is also most important is to thinking about the IT behind it, about the network server elements, that the first components that you have to manage. So if you go for open source, it's true, or basic systems that embedded in the gateway, yes, there is no reliability into it. But there are companies like ours and others who are providing really high availability capability. And when you are deploying for a telecom service provider, I've mentioned before, you need to be 99.9999% availability. So there are IT systems today available from the ecosystem of the LoRa to be able to provide critical use cases. And the best example that we are working with Motorola today. Motorola, they are doing all the emergency systems for the fire police stations. You see on the US TV shows, big radio Motorola stuff. And they are now start to embrace with the technology LoRa, and they are working with Actility, because we are really for emergency systems, fire systems, and they are completing all the telecommunication infrastructure by adding LoRa, and with this high availability core network where you have where you really limit almost to 0.000 the possibility to get a fault.
I don't know if you were asking about ruggedized sensors, but each member, depending on their location, will also aim to meet certain regulatory features. So many sensors and gateways are able to function in harsh environments also.
ATEX security systems. You will find on the ecosystem a lot of companies who really have specific segment niche regarding strong regulation, like trains, like gas, oil and gas environments. You'll find what you need.
Thank you. Sorry, but we don't have enough time for other questions because we have another presentation. So thank you very much for these presentations.